the distance formula to see if points exist on a given circle, and we're going to be able to determine the center and radius of a given circle and its equation, and then we're going to be able to write the equation of a circle given its center and radius. We'll probably get to that tomorrow. So just quickly, what are the parts of the circle? Well, a circle is a two-dimensional figure whose circumference consists of points equidistant from a fixed point, the center. So we know these things, right? A circle's radius is the distance from the center of the circle to the outer edge. A circle's diameter is the length of a line through the center from one edge to another. And the circumference is the distance around the edge. In other words, every point on the circle is the same length away from the center, the length of the radius, right? So if we had some string and we put the string here in the center and then we extended it to the edge, that would be the same length all around. And that's really the definition of what a circle is. It's a locus of points around a center point, equidistant from a center point. So a locus of points just means that we're plotting a bunch of points around this circle, like infinitely many points around this circle. But the important thing is that the radius is always equidistant. So in the grid below, a portion of the circle whose center is the origin and whose radius is 10 is drawn. Answer the following questions. What is true about every point that lies on the circle? Well, what should be true? We just discussed this. Well, what should be true is that every single point there, right? Every single point there should be equidistant from the radius. From the center. Every point that lies on the circle should be equidistant from the center. That's really what's true about this. So algebraically show that the point 6, 8 must lie on the circle. Well, how would we do that? Well, we know that every point must be equidistant. So if the radius is 10 here, like they told us, if the radius is 10, we know that the distance between the center point, right? The center is the origin here, 0, 0, and any point must also be 10. Well, how would you figure that out? The way you figure that out is you use the distance formula. So this is a formula that we used a couple of months ago, and it is x1 minus x2 squared plus y1 minus y2 squared, all under the square root, and we derive that from the Pythagorean theorem. So let's check this out. One of my points is 0, 0, because that's the center. And the other point I'm testing out is 6, 8. All right? And all we got to do is when we plug that in, we got to verify that it's equal to 10. So let's do that. So my x1 is 6. My x2 is 0 squared. And plus my y1 is 8. My y2 is 0 squared. And then this is just 6 squared is 36 plus 8 squared is 64. 36 plus 64 is the square root of 100, which is equal to 10. So since they are the same distance, we know that this point must lie on the circle since it is also the same distance as the radius away from the center point, which was 0, 0, right? So 6, 8, 1, 2, 3, 4, 5, 6... 1, 2, 3, 4, 5, 6, 7, 8 must also lie on the circle because that radius is also 10. Very cool, right? So it says it appears that 0.77 lies on the circle. Does it justify your answer? I want you guys to do that one on your own and test it out. Basically, if it's equal to 10 from the radius, right? If the distance from the radius is 10, then yeah, it should lie on the circle. It does lie on the circle. But if it's not, then it doesn't. So test it out. So this brings us to, well, what's really the equation of a circle? And the equation of a circle is x minus h squared plus y minus k squared equals to r squared, where the center is h, k, and the radius is r. Well, why is that true? Well, take a look at this problem here that we just did. Right, and this is why I didn't want to do work here. Take a look at the problem that we just did. This looks very similar to that. Now imagine, right, imagine that I got rid of this radical by squaring both sides. Imagine I get rid of that radical by squaring both sides, right? Oops. Hold on. We don't want this here yet because I did some math. If I can get my pen back and my eraser back. So imagine that before we figured out that the square root of this was 100, we were saying that it should be equal to 10, right? So imagine that we're doing this, we're squaring both sides, and we get rid of that. Look at what this looks like. 6 minus 0 squared plus 8 minus 0 squared is equal to 10 squared. Well, that's exactly what this equation says. It says x minus h squared, right? Where hk is the center. So hk is the center. Well, 0, 0 was our center. So that's our h and our k. And xy, that's just any point. And this 6, 8 was just any point there. So we derive this equation of the circle from, right? We derive the equation of the circle from the distance formula. So a circle with equation x minus 3 squared plus y plus 2 squared equals to 64 has a center point 3, negative 2. Do you see like how we're changing those signs because it was a minus here? So we know that a minus is really a plus. And then here we know that a minus, a plus is really a minus. So we have, it's always the opposite of that sign inside there. So 3, negative 2, and the radius with a length of 8 because we got to take the square root of that since it's r squared. And the square root of 64 is 8. And that's your example on how to get the center and the radius of the equation of a circle. And it's derived from the distance formula, which you guys already know, which in class, when we were in there, we derived from Pythagorean theorem. So it's all connected. Good luck. I just want you to verify this one and this one. And do these 6 quick examples. All right. Thanks. Like and subscribe, please. And always follow me on YouTube, TikTok, and Instagram. All right. Have a good one.